In this module, I will be providing you an overview of wastewater treatment. Overall, there are 3 goals for treatment. The first, and the most important for permitting and compliance, is to remove conventional pollutants. And I will define for you in the next slide what a conventional pollutant is. Beyond this goal, we would like to remove nutrients, nitrogen and phosphorus. This can be performed with biological nutrient removal, or in the case of phosphorus, with chemical precipitation. And I will cover that in the next class. The third goal is in which the wastewater treatment plant is transitioning to resource recovery. In these first 2, we're focused on removal. But as the wastewater industry evolves, we're looking to recover nutrients as fertilizer and to recover energy and capture it in the method of energy production. And so we'll talk about this in the next class as biosolids handling and as methane generation. There are also some other research lines that deal with energy production from wastewater. But again, for compliance, the first goal is simply to remove conventional pollutants. In this table, I'm giving you a list of what the conventional pollutants are and what some other pollutants also are that we are concerned with but are perhaps not required to remove. So the conventional pollutants include BOD5, which is the measure of carbonaceous and nitrogenous oxygen demand, suspended solids, oil and grease, and pH. Now I will also tell you that most permits also include a measure of pathogen indicators as well. Now for non-conventional pollutants, ammonia as nitrogen is very common, and also perhaps nitrate and phosphorus if the plant is required to do biological nutrient removal. Some of the other compounds are trace metals, hexavalent chromium, which would also provide extreme toxicity and public health risk, but also pesticides and other things that might have an impact on the receiving water body. Now when we look at the characteristics of influent wastewater, this is an idea of the spread that you would see. So here you have multiple constituents including alkalinity, BOD5, COD, suspended solids, settlable solids, total dissolved solids, total Kjeldahl nitrogen, and total Kjeldahl nitrogen includes organic nitrogen plus ammonia nitrogen, and then total phosphorus and total organic carbon. And you'll see here that municipal wastewater varies weak to strong and that there's quite a bit of variation across these. On the next slide, you'll see different industrial wastewaters listed here. And you should see that the variability of wastewater strength is much higher for industrial wastewater and is also generally much stronger than any municipal wastewater. So in municipal wastewater, a BOD5 that would be considered very strong is 300 milligrams per liter. But for industrial wastewater, that is on the low end. So considering the different wastewater treatment types that could enter a plant, wastewater treatment plants must be able to treat a variable flow rate and concentration. Therefore, treatment plants must be designed with flexibility in mind. So here I'm showing you the flow diagram of the wastewater treatment plant in your textbook. And then I'm showing you an aerial of the Lawrence wastewater treatment plant. Wastewater would come in as raw sewage, and it would pass through a series of pre-treatment steps. These would include a bar rack, a grit chamber, and an equalization basin, if required. After this, it would go through a sedimentation stage, and all of this combined is considered primary treatment. So if you look at the aerial in this picture, this portion is pre-treatment. And then the primary treatment are these 2 primary sedimentation basins. Now, before the Clean Water Act, those might have been the last treatment steps for wastewater treatment. But the Clean Water Act requires secondary treatment, And so this is defined as a biological treatment step, and it usually includes an activated sludge step plus a secondary clarification unit. And in our aerial, the secondary treatment units are here. So you have your activated sludge units here, and then your secondary clarifiers there. Now, if a wastewater treatment plant requires it, it can also have a number of advanced waste treatment steps, which would be considered tertiary treatment. These are not always present, and in the Lawrence wastewater treatment plant, they are not. Okay, so the purpose of pretreatment is to remove large objects, grit, and grease. Grit, or sand, can be very harmful for the pumps or for any further downstream equipment. And grease can be harmful for the biological step. And so this prepares the wastewater so that it can pass through the remaining treatment train without harming the infrastructure. Primary treatment includes the removal of settleable BOD and suspended solids because it relies only on sedimentation. Secondary treatment is the removal of biological oxygen demand and suspended solids, and it is biological treatment. That is the definition. Tertiary treatment is not always present, but could be considered the removal of nutrients and any other trace organics, particularly if the water is being prepared for water reuse. Now I'm going to draw this treatment train a little bit differently, because in wastewater treatment, we start with a liquid stream that has some solids in it. It passes through bar screens and grit removal, and then it goes to a primary clarifier, and then it's going to go to your activated sludge basins, and then through a secondary clarifier, and then the liquid that overflows from these will pass through disinfection and then go to your receiving water body. Now this part of the treatment train is what I considered liquid treatment. And the idea is that you remove solids and dissolved nitrogen, carbon, phosphorus. And in doing so, you generate solids. And so we need to keep track of the solids that are generated. So from the bar and the grit, you remove trash and sand. And from the primary clarifier, you remove primary sludge. And from the secondary clarifier, you remove secondary sludge. And so you've cleaned the liquid train. Only water goes to the receiving water body. We now have to deal with the solid train. And it's important to me that you understand the fate of these sludges and solids. So trash and sand will go to a landfill. But primary sludge has organic carbon in it, and it may have some nitrogen and phosphorus, which is also true for secondary sludge. And so these have some value. So some wastewater treatment plants dewater this sludge, and so both of these sludges are going to go to a dewatering unit to get the water out, to make the sludge weigh less for handling. And some of them will go to a landfill from that point. But I'd like to emphasize anaerobic digestion in this class, which is a process by which the sludge will be broken down, pathogens will be killed, and it also generates methane gas. So anaerobic digestion produces biomethane, which can be captured as a biogas. It also produces sludge, or stabilized sludge. And if that sludge is graded to be of high value and safe, then this can be land applied as fertilizer. So I told you that the primary purpose of wastewater treatment is to remove conventional pollutants. And that's true. Here we remove suspended solids and BOD in the secondary treatment step. So this part of the treatment train is secondary treatment, and we will remove all soluble BOD in this treatment step. So the conventional pollutants have been removed, but one of those further tasks is to consider sustainability. And this here the production of biomethane, and the production of fertilizer, these are sustainable solutions. Okay, so we'll just step back here and look at this. We start with our wastewater that comes in the liquid train. And the liquid passes through until it goes to the receiving water body. But during that treatment train, you produce solids that must also be dealt with. At the beginning, those solids have little value and go to a landfill. But from the primary and secondary clarifier, those sludges have carbon, nitrogen, and phosphorus that can be then further broken down to generate methane gas or to capture and stabilize sludge that can be safely applied as fertilizer.